All right, so we're just gonna pick up where we left off. Um, so here, the arc length problems that we're gonna be working on, we're actually gonna be solving for the arc length by hand instead of with a calculator. So the first problem that we have here is y equals 1 plus 6x to the power of 3 over 2. And we have to calculate the arc length from x is equal to 0 to x is equal to 1. So let's try and solve this problem. All right, so first things first, we have to identify the f of x, right? Our f of x is 1 plus 6x to the power of 3 over 2. Then we have to take the derivative. So we're going to say our f of x is 1 plus 6x to the power of 3 over 2. And now we want to take the derivative. So the derivative here, derivative of 1 is 0. And over here we have a power function, so we just have to apply the power rule, right? So we take the exponent, we bring it down as a coefficient. It's going to multiply the 6, right? So we're going to have 6 times 3 over 2. And then we're going to multiply by x, and we're going to reduce the power by 1. So this will give us x to the power of 1 over 2. All right, so this simplifies out to be 9 times x to the power of 1 over 2. And now what we're going to do is we're going to square the derivative. Right, so if we square this function, we're going to get 81 times x. Right, so let me write it like this. F prime squared is equal to 9x power of a half squared, which is 81x. Okay, so at this point what we want to do is we're going to add 1 to it and take the square root. Right, so our 1 plus f prime squared square rooted is the square root of 1 plus 81x. And now all we have to do is integrate this from point A to point B, right? So our point A is x is equal to 0, and our point B is x is equal to 1. So we're going to write our arc length as the integral from 0 to 1 of the square root of 1 plus 81x. Now, instead of writing the square root symbol, I'm just going to raise this to the power of 1 over 2. Right, so I'm going to write it as a power function. And the reason I'm writing it this way is so that when I apply the power rule to this integral, it's a little bit easier to see the process that I'm doing. So to solve this integral, we're going to have to apply the u substitution method. And why is that? Because if you look at what's inside of the parentheses, the 1 plus 81x, if you take the derivative of 1 plus 81x, right, your derivative is just a constant, right, just 81. Right, so you can think of this expression as being multiplied by a constant times dx. We think of the derivative of x as being dx. So let me explain what I mean. See here, so we can say our u would be 1 plus 81x, which means our du is equal to 81 times dx. Right, so if we solve for dx here, we'll find that dx is equal to du divided by 81. And now we can make these substitutions. Right, so we can rewrite this integral. Instead of using 1 plus 81x, we can write u to the power of 1/2. And instead of dx, we can write du divided by 81. Now, another thing we have to do is we have to change the bounds of the integral. Since we're changing from variables of x into variables of u, we have to make sure that the bounds reflect that. So the way we do that is we set x to be 0, right? So we know x is going to range from 0 to 1. So we're going to set x to be 0. So we'll say at x equals 0, our u is going to be 1 plus 81 times 0, right? Which is just 1. And then when x is equal to 1, right, so we'll say at x equals 1, our u is going to be 1 plus 81 times 1. So this is just going to be 82. Which means that instead of going from 0 to 1, right, our bounds are now going to go from 1 to 82. Right, so we're going to say integral of 1 plus 81x to the power of a half dx is equal to the integral from 1 to 82 of u to the power of 1/2 times du divided by 81. Let's see, let's write this a little bit clearer. Right, so notice that the u is being raised to the power of 1/2, just like the 1 plus 81x was also being raised to the power of a half. So this is a lot simpler to deal with than this function here, right? Because the du over 81, the 1 over 81 here, we can bring it out as a coefficient. Right, so now we have 1 over 81 multiplied by the integral from 1 to 82 of u to the power 1/2 times du. Now, u to the power of a half is just another power function, and if we integrate that, according to the power rule, we're going to add 1 to the exponent and divide by the new exponent. Right, so this is going to be 1 over 81 multiplied by u to the power of 3 over 2 divided by 3 over 2. Right, and we want to evaluate this from 1 to 82. Okay, so let's simplify this a little bit. So what we have here is 1 over 81 times 2/3 times u to the 3/2 from 1 to 82. And let's see, we can write this as 2 divided by 243. All right, now all we have to do is just evaluate this function from 1 to 82, which means we're going to evaluate at 82 and then subtract the evaluation at 1. So we're going to need a little bit more space here. Let's remove this. And let's do that calculation over here. So we're going to have 2 over 243 at 82 to the power of 3 over 2 minus 2 over 243 at 1 to the power of 3 over 2. Right, so now let's just factor out the 243 and clean this up a little bit. And for this kind of problem, it's fine to leave it as an expression like this because we're asked to solve this problem by hand and without a calculator, right? So if you reach like a certain fraction or value you can't really simplify any further, it's okay to leave it as is.